Hello and good evening everyone. So in this video we are going to talk about arrays and also strings. Okay, so firstly we need to understand what an array is. An array is simply a contiguous memory areas that hold a number of values of the same data type. So what I'm trying to say here is, assuming you want to store the scores of a student, or let me say the score of 5 students. So instead of you to declare different variables to store information of these 5 students, then you can create an array. And this array is going to store what? The scores of this student. What I'm trying to say is, assuming you have 5 students, you need to say int a, and then you need to initialize the value 5, and then you have another student, let's say int b, you initialize the value, the score, to int c, something like this, up to, let's assume 3 students. Right, you have this 3 students here. Let's say this is going to be student 1, student 2, and student 3. Right, so as you can see here, for you to store this scores of this student, you need to do something like this. So if you have 100 of them, you need to do the same thing. So in this case, as you can see, you are declaring variables, different variables. So you can create an array that is going to store these 3 scores here, or this information here. Okay, so how do we declare an array? To declare an array, the first thing you need to do is you need to specify the data type of what you are going to store in that array. Now in this case, I want to store an integer because I'm storing 5, 2, 3, right? It's an integer, so I just say int. So the next thing is I need to give the variable a name. What is the name of my array? So let me call it score, for instance. So the next thing is you need to give it the size. Do you get it? You need to give the score, the array size. How many elements do you want to store in the array? So in this case, I want to store 3 elements because I'm storing scores of 3 students. So I need to pass 3 here. So now I have declared an array which is called score, and the size of this array is what? Is 3. Do you get it? This is simply declaration of array. So how do I initialize this array? Now, how do I initialize the array? Let me try initializing. I want to, how do I increase the size of this thing? Okay, here. Yeah. So I want to initialize the array to hold these values 5, 2, and 3. So I'll simply say equal to, I will open a curly brace here. So I pass in the first value, which is 5, comma, the second value 2, comma, the third value 3. So now I have an array of how many characters, of how many elements, of 3 elements. Do you get it? This is how to declare an array. So that's simply what an array is. So as you can see here, we are only storing what? Integers in this array. So you cannot store a character in this array because from the array declaration here, you said that it is going to be what? An integer, an array of integers. Do you get it? So let's say I want to store characters. If I say car, that's for characters. So let me just name it, for instance, let me just say A. So how many characters do you want to store here? Assuming I want to store, let's say happy, we have H, A, double P, and Y, 5 characters, right? So I give it 5 here. So all I need to do here is I'll just say it's equals to, then I will open this bracket. Inside a single quote, you add your what? Your H, right? Then a comma, right? Then after H, you add what? A again. All within what? A single quote, because these are all characters, right? And then P, all within what? A single quote. And then what? Another P within a single quote as well, comma, then the last character Y. So this is what? An array of characters. It contains what? Happy now. Do you get it? These are array of characters. So another way to do this now is I can simply say car, and let me call it B this time. Let me just say, sorry, let me call it B. So let me give it the size is still 5. So I can just simply say equal to, then in double quotes, I can pass in HAPPY. This is what? This is a string. Anything enclosed within double quote is called a string. We are going to talk more about string later when we're done talking about arrays. But for now, all you need to understand is what an array is. And you've seen how to declare an array and how to initialize the array, isn't it? So now let's refer to our terminal and let's do something about this array. Okay, so let me create a file. Let me call it tests.c. test.c. Wow. Yeah, so hash include. All right, so now I want to declare an array to store 5 values. So I can simply say int, and I can say a 5 here. I've showed you how to initialize, right? You can simply do something like this: 1, 2, 3, 4, and 5. So this is what initialization of the array. We've declared the array and we've also initialized it. So one thing you need to know is that indexing is how we use to access the element of an array. So when you look at this is the first element, right? 1, 2, 3, 4, 5. So in this case, the first element in an array begins with what? Index 0, followed by index 1, followed by index 2, followed by 3, followed by what? 4. This is how they are stored in any array. Okay, this is how they are stored. The first element does not begin with index 1. No. To access it, you don't use you don't say this is in index 1. No, because it is the first element. No. The indexing begins from 0. So you have index 0, index 1, index 2, index 3, index 4. So if you have 5 elements in an array, the last element is going to be at index 4 because it's starting from 0. If you have 20 elements in an array, the last element is going to be at index 19 because when you count from 0 to 19, that's how you get 20. Do you get it? So now let's try something here. Let's say I want to access this element here. This is in index what? Index 0, 1, 2. It is in index 2, right? So I can simply say printf and then pass in what? I'm printing an integer, right? So I'll say %d on a new line, then I'll pass a comma. So how do I access index 2 of this element? First thing I need to do is, what is the array name? The array name is what? Is A, right? So I'll pass in A and then open a square bracket, and inside this bracket I will now pass in the index of the element in which I want to fetch. I want to fetch 3. Which element, sorry, which index is 3? 0, 1 to index 2, right? So I just pass in 2 here. So I'm expecting this to print the value 3. And let's test this and see. So if I say gcc test.c, let me give it the name t. Wait, it says okay, I'm supposed to give a space here, not there actually. All right, so it has been compiled, so let's run it. So did you see that I got 3? So this is simply indexing. So if I should change this now, instead of 3, let me make this 0. Let's say 0 like this, 0. So I'm expecting this to print what? 1, because 1 is the 0th index, right? So let's compile again and let's run it. So did you see that I got 1 printed? So using the index, that's how you'll be able to get the element at a particular position in an array. Okay, so another way of initializing an array is this. If I like, I can just declare the variable here, sorry, the array. After declaring the array here, I've declared A, right? So here I can simply say A index 0. So now I'm storing the element at index 0. Let's say I want to store 20 at index 0. So this is what will be stored at index 0. And this index 1. So let's say I want to store 25 at index 1, right? So I will go to A index 2, right? And this is going to be, what should be in index 2? Let's say 30, right? So let's say A index 3. So now I have 4 elements here. Let's say 40 here, right? So you can initialize your array like this as well. So as you can see here, I forgot to give it a size here. The size of my array is going to be 4 because it's storing what? 4 elements here. Okay, so now let's try printing A index 0. We've already set A index 0 to be 20, right? I'm just trying to show another form of initialization. Okay, so let's compile this again. So gcc and let's run it. So did you see that I got 20? Because 20 is what is in index 0 of this, right? So if I should make this index 3, let's try printing index 3. Let me try printing index 3 here. All right, so let's see. Compile. So did you see that we got what is exactly in what? In index 3. So what happens in the memory when you do something like this is, or before we move to that, let's just try printing something. All these elements you are seeing here, they are stored in an array format. We've already seen that. And what did we define an array as? We said an array is what? An array in C are contiguous memory areas that hold a number of values of the same data type. Why is it that these arrays are contiguous? Why? So the reason is simply this, or let me not tell you, let's just see it practically why they said array is contiguous. Okay, so I want to print the address of all these elements here. Index 0, where is this stored in the memory? Where is this stored? Where is this stored? Where is this stored as well? So I want to print them, right? So let me try printing this. before that, let me not print this value. Let me just say I want to print the address, right? So I'll just say %p, right? I'm printing what? I'm printing address, right? I will just say %p and then /n. I would just say ampersand. That's how we get the address. So what is the value? I'm trying to get the address of a index 0, right? So I'll pass in a index 0 here. Do you get it? This how I'm supposed to do this. So let me do for the remaining as well. So this is going to be %p, right? /n ampersand a index 1, right? So this will fetch the address of a index 1. So printf again %p /n ampersand a index 2, right? So printf again, right, %p, right, %p /n, then what, ampersand a index what, index 3. So I'm expecting this to print what the address is of this what, of this arrays here, of the each index of the array here. So now we are going to see why they said array is a contiguous memory location, are stored in contiguous memory location. So let's try compiling this, gcc, and let's run the compiled file. Let me open the file here so that we'll be referencing to it. So when you look at this array has been declared as what? As an integer. It's only going to store integer, right? So an integer in a 64-bit machine holds how many bytes? We've talked about this when we're talking about pointers, right? When we're introducing pointers. So it holds how many bytes in the memory? 4 bytes, right? Integer. So when you look at this, for the first declaration or the first initialization, which is 20, this is the address, right? So take note of this last character here, which is 0 in this case. So when you initialize the second variable, what is in index 1, you know that for this 20 here, it is going to what, allocate 4 bytes, because you've declared that it is going to hold an integer. So it's going to allocate 4 bytes, right? So after allocating 4 bytes, it started from where? From 0, right? Just look at this last digit here, 0, right? So it means that it will have to go 4 bytes to store the second element, which is 1. So if you count from 0, 1, 2, 3, 4, right? So that's why we are having this stored in memory 4. That is this one here. So this one also, since it is an integer, it will go 4 more bytes again in the memory to store the second one. So that's why after 4 here, when you add 4, you get 8. That's how we got the address of this. So when you add 8, so that you get the address of this, you get what? You are going to get 12, right? So, but in this case, 12 is not represented as 12. It's represented in what? In hex. And C is what? Hexadecimal representation of 12. Okay, so 12 is C in hex. So that's why you are seeing what? C here. So as you can see, the memory, the way they are stored is what is contiguous, because the first one is 0, 4, 8, C here. So it's just giving 4 bytes. This is showing you that, yeah, you are storing an integer, because each int, each declaration, each variable here, each element, it needs how many bytes? 4 bytes. So it will allocate 4 bytes and then move to the next 4 bytes to store the second element, and move to the next 4 bytes to store this, move to the next 4 bytes to store this. So that's why they are in this format. So that's why they are said they are contiguous. Okay, it means they are arranged in order. Okay, they are not, it's not that they will be allocated a space here, then randomly go to another place and allocate a space of the same array. No, it's not going to do that. So that's why arrays are stored in contiguous memory location. So, and we've seen how to get the addresses of this array, right? I believe this is clear. So this is simply array. Okay, so now in brief, let's talk about what a string is. Or before that, let's do something like this. We've seen what? Array of integers, right? So if I should do something like this now, let me just remove all of this. I just want to show you how we can declare arrays of characters. So here, if I say car, let me call it A, and let's say it's going to take 5 characters as well. So I said we can do something like this. Just declare this. You can just say H, right, comma, A, comma, P. As you can see, I'm enclosing all of them in a single quote because they are what? Characters, right? So Y here. So this is what? Declaration of a of an array of a character. So this is only going to hold character. You cannot store float, you cannot store integer here. So same as the previous example, we can use the index to fetch each element here. So if I should say printf here, since I'm printing a character, what is the placeholder? I'm supposed to use %C for printing characters. So I will pass in a comma. So let's say I want to get this last element, which is y. So this is index 0, index 1, index 2, 3, and 4. This is index 4, right? So I will say what? A index 4. So I'm expecting this to print what? The element of what? Or the fourth, the element at the fourth index of A, which is what? Which is y. So let's compile this. GCC. So let's run it. So as you can see, I got what? I got y. So even for the case of characters, it is the same thing. As far as it is an array, it is the same way you will need to follow to access each element of the array. So in another way, to declare an array of characters, instead of doing something like this, you can simply do this. Just put this within double quotes. So when you put this within double quotes, you are telling your compiler that, okay, you are going to pass string. So this is what a string is. So here I'll pass in what? Happy. So simply, this is what a string is. A string is a character, or let me say, is a combination of two or more characters. Okay, if you have more than one character, it is a string. Assuming I have just H here, this is not a string because we just have one character. And if I'm to compile this now, I'm going to get error because I am not supposed to enclose a character within a double quote. I cannot do that. I can only enclose strings within double quotes. So that's why I need to pass in more than two. I need to pass in two or more characters. Do you get it? So same as the same the way we did initially, this is also in index format. H is what? Is in index 0, A index 1, index 2, index 3, index 4. So any string that you declared in C, it is stored in what? An array format. So assuming you have this happy, let me try to explain this here. You have happy, H A P P Y, right? So you have something like this, H A P P Y. So they are stored in array format as well. So this is index 0, index 1, index 2, sorry, my index 2, index 3, and what? And index 4. Sorry about this, my handwriting. So index 0, 1, 2, 3, and 4. So these are all, they are also stored in an array format. So strings, just to know this, strings are stored as an array. Okay, so this is simply what an array is. So let's see, how is this thing represented in the memory? So let me open my memory template. So initially we have something like this, right? Or before that, let me delete this. So let's assume we have this now. This is what? Score. Let me rename this. Instead of score, let me just use a short name. Let me call it A. No, let me not call it A. Let me call it Z, for instance. So the array name is Z, right? So the moment you do something like this, int Z3, so it means that you are going to store an integer and you're storing 3 integers. So what will happen is this. What is the size of int on a 64-bit machine? It is 4, right? So it will multiply 4 with 3. 4 times 3 is 12. So it will allocate 12 memory. Okay, it will allocate 12 bytes of memory for you. And this is what will happen. So here we have what? Z index 0, right? So for Z index 0, let's assume I'm starting from here, 1, 2, 3, 4, right? So here I can match this. So this is going to be what? Z index 0. Oops, why is it not writing here? Yeah, so Z index 0. So now I have Z index 0 here. So the next 4 byte is going to be what? Is going to be Z index 1, right? Sorry, Z index, Z index 1, right? So now it will move to the next 4 byte again, 1, 2, 3, 4, and it's going to store what? Z index what? Index 2 here in this case, index 2, because we have 0, 1, 2, we have 3 elements, so it's going to start from 0, 1, and 2, isn't it? So now these 4 bytes here, these 4 bytes allocated for each of the index, we are now going to store the element inside this. So in this case we have what? 5, right? And here we have what? We have 2, isn't it? Imagine. So here it's going to be 2, and then here it's going to be what? Here it's going to be what? It's going to be 3. So I will merge and then I'll paste 3 here. So this is how it is stored. So as you can see, it is stored in contiguous memory location. That's what I'm saying. Initially 4 bytes, and then the next one will be what? Another 4. So for us to get the address of this, it will be what? 4 byte difference. So initially, as you can see, the address of this first index is 60. So for this, it will be 64. That's what I just explained on the terminal. It will be 64. After 64, when you add 4 to it, it's going to be 68. So that's why we are getting this. Okay, so this is how this is stored in the memory. Okay, this is how this is stored in the memory. So I think this is all we need to explain about arrays and also what a string is. Okay, don't worry, we are going to go deep into all these things. This is just an introductory part of this concept, arrays and also string. In the next session, we are going to begin solving examples on pointers, arrays and string. So thank you very much. Till meet in our next session.